So far, we've identified two sources of economic costs incurred by firms. The first arises from the need to hire labor. The second arises from the need to hire capital. We've also assumed that labor can be varied in the short run, whereas capital cannot and can only be adjusted in the long run. As a result, we've said that labor is a real economic cost in the short run, whereas capital is not, but both are real economic costs in the long run. The reason for the short-run distinction is that an expense that a firm incurs is only a real economic cost if the firm in fact has some control over that expense. If capital is indeed fixed in the short run, then the expense associated with that capital has to be paid regardless of how much the firm produces or whether the firm produces at all. It is therefore not a real economic cost of producing in the short run. The expenses incurred by a firm in the short run are therefore different than the firm's economic costs, and we'll illustrate this here. Suppose capital is fixed at 100 units in the short run, and the firm can only vary its labor input. It is therefore operating on the slice of its production frontier that holds capital fixed at 100. Suppose further that along that slice, the firm has initially increasing marginal product of labor, but eventually diminishing marginal product of labor. This means that in the short run, it initially gets easier and easier to produce, but eventually gets harder and harder to produce. The resulting short-run cost curve that has capital fixed at 100 units, therefore has an initially steep slope that gets shallower and shallower, but eventually becomes steeper and steeper. In other words, the cost curve tells us that initially it gets cheaper and cheaper to produce additional units of output, but eventually it gets more and more expensive to produce additional units of output. This short-run cost curve contains only the cost of labor, because capital is a fixed expense that has to be paid regardless of whether the firm produces or not. The short-run cost curve, in other words, contains all the variable costs associated with producing in the short run, which in our case is simply the cost associated with hiring labor. When we add to these variable costs the fixed expenditure associated with paying for the 100 units of capital, it shifts the short-run cost curve up by the amount that it costs to pay for the 100 units of capital. We therefore have a total expenditure curve given 100 units of capital that is the same as the short-run cost curve, except that it also includes the fixed expenditure on capital that doesn't change as we produce more. The short-run marginal cost curve is then simply the slope of the green short-run cost curve in the upper graph. That green curve has a slope that's initially becoming shallower and shallower, implying that the marginal cost curve in the short run will initially be falling, but eventually the green slope becomes steeper and steeper, implying that the marginal cost curve will eventually become upward sloping. Note that the marginal cost curve is also equal to the slope of the magenta total expenditure curve, because the magenta total expenditure curve has the same slope at all output levels as the green short-run cost curve. This is because the only difference between the two curves is that fixed expenditure on capital, which doesn't vary across different units of output. The short-run average cost curve is also derived from the green short-run cost curve in the upper graph, with the average cost simply equal to the overall cost divided by the level of output. As we've seen in previous chapters, the average cost curve begins at roughly the same place as the marginal cost curve, is downward sloping as long as the marginal cost lies underneath it, and becomes upward sloping when the marginal cost lies above it. As a result, the marginal cost curve must cross the average cost curve at its lowest point. The average expenditure curve, on the other hand, is equal to the total expenditure divided by the output level. And since the total expenditure curve lies above the short-run cost curve in the upper graph, the average expenditure curve will lie above the average cost curve in the lower graph. However, it doesn't shift up parallel as the total expenditure curve did relative to the short-run cost curve. because as output increases, the fixed expenditure will be a smaller and smaller amount of the total expenditure on average. And for the same reason that the marginal cost curve must cross the average cost curve at its lowest point, it must cross the average expenditure curve at its lowest point. For the first unit of output, the fixed expenditure is the same as the average fixed expenditure because we're only producing one unit of output. Therefore, for the first unit of output, the difference between the average expenditure and average cost curves is exactly equal to the fixed expenditure on capital. In Chapter 11, and then again in Chapter 12, we derive the supply curve for the firm as the portion of the marginal cost curve that lies above the average cost curve. In our short-run picture here, the supply curve for the firm will therefore be the darkened portion of the marginal cost curve that lies above the green average cost curve. As we'll see a little more clearly later, the firm does not need to cover its fixed expense on capital in order to operate in the short run, because the fixed expense on capital has to be paid regardless of whether the firm produces or not. In order to decide whether to produce or not, the firm simply has to decide whether it can cover its short-run costs, not its overall short-run expenses. And if it can, then it's rational to produce. It will be able to cover its short-run costs so long as price is above the lowest point of the average cost curve, which is why its supply curve is equal to the portion of the marginal cost curve that lies above average cost. We've shown that one way to illustrate the size of the fixed expenditure on the 100 units of capital in the lower picture is to do so at the output level 1. At 1 unit of output, the fixed expenditure is the same as the average fixed expenditure and is therefore the difference between the magenta average expenditure curve and the green average cost curve. There are, however, many other ways of showing the size of the fixed expenditure in this lower graph. We'll illustrate one of them here, in particular one where we assume that the firm is producing an output level XA. At that output level, the firm is incurring an average cost that's given by the height of point A, and an average expense that's given by the height of A prime. The difference in the height between A prime and A is then the average fixed expenditure given that we're producing the output level XA. In other words, it's equal to the fixed expenditure divided by XA. Multiplying the vertical side of our rectangle, which is the average fixed expenditure, times the horizontal side, which is our output level, we then get back the fixed expenditure on the 100 units of capital, because fixed expenditure is equal to average fixed expenditure times output. Given where the supply curve for the firm is, we know that the firm won't actually ever produce the output level XA, but we could pick any other output level and also illustrate the fixed expenditure on capital as a similar rectangle. That rectangle will get shorter and shorter and wider as the output level increases, because the average expenditure and average cost curves are converging towards one another. All of these areas must be equal to each other and equal to the vertical distance of the fixed expenditure at output level of 1. This is one way to see why it is, in fact, that the average expenditure and average cost curves have to converge to one another.